Hello, today I'm looking at M3 International A-Level May 2015. This is question 1. So I have a hemispherical bowl of internal radius r is fixed with its circular rim upwards and horizontal. A particle P of mass m moves on this smooth inner surface of the bowl. The particle moves with constant angular speed in a horizontal circle. The centre of the circle is at a distance of half r vertically below the centre of the bowl, as shown in figure 1, and the time taken by P to complete one revolution of its circular path is t. Show that t is equal to this. So remember, in a show that question, we can't assume this and we can't use this. So basically they're asking us to work out the time taken to do one revolution. And we need to remember that the formula that we have for that is t equals 2 pi over omega. So basically I need omega so that then I can work out what t is. So if I begin with a diagram, then I'll draw the centre of the upper circle here. I'll draw half r here. I'll draw r here. And then I'd have the same distance down to about here. And so the particle is moving in this, the particle is here, and the edge of the bowl would be the circle or arc of the circle here, but the particle is actually moving in a horizontal circle kind of around this point here. So this distance is r, and the forces acting on the particle will be the weight. Now the mass is m, so the weight is mg. There will be a reaction towards the centre of the bowl, so let's call that capital R. Here I could work out what theta is. And if I just draw a dotted line in here, then I have that same angle theta there. But because the circle that this is moving in is actually horizontal, then the acceleration is acting towards the centre of the circle, which is actually here. So for the acceleration of the particle, towards the centre of a circle, I can either use r omega squared or v squared over r. In this case I'm interested in omega, so it would be a better idea to use r omega squared. So the radius of the circle is not r though, because we're looking at this as the radius here, from here to here, not the radius of the bowl. So I need to work out what this is. So if I have r is the hypotenuse, r over 2 is this length, then this length here will be r squared minus this squared, all square rooted. So this would be 4r squared over 4 minus r squared over 4 would make 3r squared over 4, all square rooted. So the radius would be this, which is root 3. R squared square rooted would make r, 4 square rooted would make 2. So that is the radius of the circle multiplied by omega squared. Okay, so now I'm ready to use Newton's second law here. So if I apply Newton's second law vertically, then I can get r in terms of mg. So r cos theta is equal to mg. So at this point, let's try to get what cos theta is. Cos theta, using this triangle, is the adjacent r over 2 divided by the hypotenuse. So that will make a half. And so then I can just get that r divided by 2. So r times cos theta, r times a half, makes mg. So now I know that r is 2m g. Now if I do Newton's second law towards the centre of the circle, so now I have Newton's second law, so I do r sine theta equals the mass times by the acceleration, but I know what r is, it's this, 2mg, and sine theta, well, if cos theta it was a half, then that means sine theta will be root 3 over 2. So here I get a root 3 over 2 equals m root 3 r over 2 omega squared. Okay, so now I'm trying to get to omega so that I can pop it in here and get what t is, the time to do 1 revolution. So let's see what we can tidy up here. I can divide both sides by m. I can divide both sides by root 3 over 2. And I could divide both sides by r, so that I end up with omega squared is 2g over r. And now popping the square root of this into here, then I get t is 2 pi divided by the square root of this, and that will make 2 pi multiplied by the reciprocal of this. That's not quite the same as what they said, but that is because 2 can be written as the root of 2 multiplied by the root of 2. So if I were to write this as pi 4r over 2g, because 2 is the same as root 4, then these two would simplify to give me a 2 inside here, and then I'll just rewrite it so that it's nice and clear, and then I've ended up with exactly the same expression as what I was given here. Okay, so that question is worth 8 marks. I hope you found this solution helpful. Good luck with your revision.